So I'm one of the co-founders of Redshift Rendering Technologies, and we make Redshift, which is the first biased production quality renderer that uses GPU acceleration. So this talk, I'm going to go a little bit over some of the features that we've added since our talk at GTC and Siggraph last year. So we've got quite a lot of ground to cover in this talk. I'm going to skip straight to it. So basically what we've been doing is trying to shrink the feature gap between popular CPU renderers and our render, the GPU renderer. So here are some highlights from 2017. So first off, we added like a triplanar shader. And what this is, it's like a great little shader node that you can insert anywhere into your shader graph. And it projects UVs on each axis based on object topology. And this is like especially useful if you have like objects that are very difficult to unwrap for like traditional UV baking. Or if you want to do something like crazy, like have different textures on, like, say, the sides of an object versus the top of an object, like a snowy mounty peak or something like that. And it's also very flexible too. So actually, you can do like bump mapping and displacement mapping with it without any extra setup. It just works. And also we support like root pose data as well. And what this means is that if your object is deforming, the UVs will stick to it. They won't swim around and be all ugly and horrible. So we also added trace sets. This is more of like a power user feature. And what this means is that you can say what rays an object can see. And that's like for reflection, refraction, GI, subsurface scattering is probably coming soon as well. And the added like benefit of adding this technology in the core meant that we could add some cool little features that people have been asking for over the years, like they want to say only include their selves when they trace AO or subsurface scattering, so we added that too. And this is quite a big one. For last year, we added the Redshift render view. First and foremost, this brought like massive interactivity improvements, especially in Maya, and we're going to be further improving that as well over the next few months. And it also brought like open color I/O support for like exotic gamma control, like ASIS and things like that. And also the ability to view AOVs in the render view as well, so you can see everything, all the AOVs as well. And we're actually like building on the render view as it speaks, as we speak, adding new features like A/B comparison and post effects as well, which I'll be telling you a little bit about later. And this was another big one as well. This is like more for the power user guys. So custom AOVs. So we actually like announced this last year at GTC and Siggraph, and we decided that we would sort of deviate from the original plan. We had like several shader nodes in mind. We decided to like consolidate those into like one shader node to make it easier to set up. So consequently, you have like an AOV shader node that can do both beauty pass-through and write to AOV files at the same time. So really easy to set up. And so when we did this, we wanted to make sure that it was very fast, so the custom AOVs actually run concurrently with the beauty. It's not like a separate pass or anything like that. And it also kind of laid the foundation for sort of more exotic AOV technology, which I'm going to tell you about now. So this is like a fairly big one this year. So light group AOVs. So these are like, a lot of special effects studios are asking for these, and what they can do is that they can basically say, you can separate all your different lighting contributions for different lights, and you can spit them out into AOV files, and you can take those AOV files and then actually tweak the lighting in comp instead of re-rendering your scene, which of course is way faster than re-rendering your scene. So it's really easy to set up in Redshift. The way you do it is that you invent light group names. You assign the lights to those groups, then you tag your AOVs, your lighting AOVs with those light groups, and we can split up between like reflection, refraction. We can do direct and indirect lighting as well. And this means that you capture everything in the scene, all the light bounces. And if there are light bounces from things like emissive objects, those can go into a separate AOV, so basically you will lose nothing. So once you have all that data, you can bring it into your comp package of choice. You just add all those AOVs together and you get the beauty. So it's that simple. And just like our custom AOVs, we're like always very careful to make sure that these things are fast when we add them. We want to make sure that they don't actually like have any impact on render times when they're not enabled. And so these actually run concurrently with the beauty shading as well. So another big ticket feature was Raytrace subsurface scattering. So this is something that people have been asking for quite some time. So we always did point-based subsurface scattering in Redshift, and point-based is a really great technique for getting very quick results, very clean results very quickly, but it does have like some caveats. Like you can have like certain geometric edge cases where the wrong point gets picked and it just looks weird. Or if you have like animations, you might get some flickering here and there. Well, Raytrace subsurface scattering does not suffer from any of those problems. And also Raytrace subsurface scattering is needed for progressive rendering, which is used in IPR mode. And this was never actually supported with point-based, so we've had quite a few. We had customers in the past come from like a progressive rendering workflow, and they'd start filing bug reports with us saying, you know, when I enable subsurface scattering, it doesn't work, it looks just like diffuse. Well, that's because we didn't actually support it, because we didn't have Raytrace subsurface scattering, but we do now. So one question that we get asked is like, how much slower is Raytrace going to be next to our very fast point-based? And the answer is that it's fast. And so basically we engineered like a very, very high performance importance sampling algorithm. And what this means effectively is that when you're actually like shooting your rays, you don't waste any samples. You use those samples to pick the best quality results as you're doing it. So it should be very fast indeed. And in fact, importance sampling is hugely important when you have like multi-layered subsurface scattering. So you want to like get all those, you want to actually pick the right colors for those layers without wasting any time at all. And another question was like, is it comparable to point-based? So yes, it is to a certain degree. We actually have the option on per material. You can like switch between point-based and ray-traced if you like. And it does look the same except for one slight caveat. Our point-based technique, actually we did this trick of like normalizing the lighting based on like object density. Don't ask me why we did it. We just did it because it looked nice. But it's actually not physically correct. So thankfully with like ray-traced solution, we don't do that. We can't even do that. So ray-trace is going to be actually properly physically correct. And another thing that we wanted to achieve when we added this technology is to make it flexible. So in the future, if we like decide to add more exotic subsurface scattering profiles, we want to make it like really easy to add that super quickly and have all the important sampling work just out of the box. And this is going to be super important as well for when we unveil our shader SDK, where not only are you going to be able to write shaders, you might be able to like write your own subsurface scattering algorithms as well. So one big release this year is Redshift 2.6. I think that we've had like an experimental version for some time, and I think the official one came out a couple of months ago. So the first and foremost with Redshift 2.6 is we added denoising support. So everybody loves denoisers at the moment. Everyone's talking about them, and admittedly, like we were kind of hesitant to like use a denoiser. You know, we were thinking, well, if Redshift is fast enough, why would we need a denoiser? Well, there are some cases where scenes can be particularly tricky to clean up, so a denoiser, a really good denoiser, can add that extra bit of final polish to a frame. And so it was important for us that because denoisers do need a fair few number of samples to get really good results, that we would actually like, we'd have to have a denoiser that could do production quality rendering. So in the end, what we did is we chose 2 denoisers for Redshift. So first off, we chose Altis. And this Altis, the Innerbright guys, we'd actually been talking to them for a few years. It was purely by chance. We met at, I think it was GTC in 2015, and they showed us some of their tech. And we thought, well, that's interesting, but we don't care right now. But we kept the relationship going, and in the end, this was the first denoiser that we integrated into Redshift. So the Altis denoiser uses like tried and tested like wide bilateral filters, but it does have some extra secret sauce that kind of makes it, we think, better than the rest. And it's this extra secret sauce that makes this, in our opinion, our production quality denoiser. So it can handle like very large scenes, and it can handle animations without any flickering or introducing any artifacts like that. So we're pretty impressed with this. And if you're actually interested, I do recommend that you visit their website because they actually do give a discount for Redshift customers. And here's an example. So this scene, this nice little toaster here, was rendered with like about 16 samples on the left, and you can see it's very noisy. You've got some depth of field in there, which actually really shows off some of the noise. And on the right, you can see this is with the Altis denoiser. You can see that it's done a pretty good job of taking away all that nasty kind of noise from the depth of field, and that's just with 16 samples. Okay, so the second denoiser we added was optics. So optics denoiser is not like Altis denoiser. It uses AI and deep learning to best guess what an image should look like. So it's kind of magic, but it works. And so when NVIDIA kind of told us to like test this, they were telling us that they actually used many thousands of hours of like super incredibly high quality images from Iray to train this neural network. So we were kind of like skeptical and thought, why would Iray images in a neural network, why would those work well with Redshift? So we tried it, and we were actually pleasantly surprised because not only were the results pretty good, maybe there's some cases where they could be kind of splotchy, but they were very fast, which I think is very important to some people. So we think that this is going to be like a really good denoiser for some previs work and maybe for like certain stills rendering as well. And also in the future we're going to be training it with Redshift images, so hopefully we'll get better quality even yet. Example. There's the nasty 16 samples on the left again, and then you can see an example of the optics denoiser doing the 16 samples as well, and you can see it's done a pretty good job of cleaning up that noise in the depth of field while actually maintaining the quality. So we've had some other cool features with Redshift 2.6. I'm just going to go over these now. So first off, we added some a global volume shader support. So we always had like global volumes, like got volumetric fog and single scattering, but you couldn't actually apply a shader to it, which meant it kind of looked kind of flat and boring. So you can now use like 3D procedural textures to add like kind of wispiness and clouds to your scene, kind of makes it look more interesting. But I have to stress that this only affects the single scattering component, the lighting component. It does not affect transmission. Transmission requires ray marching, and that's actually pretty expensive to do if you're going to be using a shader to define ray marching. It's not totally out of the question. We're thinking maybe we'll look into this for like Redshift 3.0 and the shader SDK, so kind of watch this space. The second thing is fun, Cryptomat. So this was developed by Jonah Friedman at SciOp. And what this actually does, it attempts to solve the matte coverage problem. And what I mean by that is that traditionally, when people like bake out their matte images, these are like flat colors. But if you have like matte objects overlapping, and you have like depth of field, like strong depth of field, or strong anti-aliasing filtering, all those matte colors get blended together, and you just can't use them in comp. It becomes a real nightmare. So Cryptomat is different. It actually works on like a subsample level, which means you get all the data like from the subsamples, and then when you're in comp, you can actually like comp that together, and all the depth of field will work, and it just looks clean. It's fantastic. So we're excited about that. So barn door area light spread. This was something that people have been asking for some time, and I kept promising it, but I never delivered. Well, in 2.6, you can actually have the area light spread. So it's basically what it means is that you can take an area light and kind of turn it into a spotlight. So you can kind of focus the light rays in a specific direction, almost kind of like a laser beam. So we had to like change our important sampling algorithms for this to make sure it was very clean and fast. So we're pretty happy with this. And this one is a little bit tricky to explain, but I will try. So we added like improved speculars through refracted objects. Now what I mean by this is like if you have like a lens where the light is bending and the light passes through it, you would expect that light to bend as well to actually look physically correct. Well, that's not normally what we do with rendering. Like we have direct lighting, which means that a specular ray will go straight to the light, which means anything in between, whether it's refractive or not, the ray will not bend anyway. It does not actually look correct. We had lots of complaints about this. So in order to make our scenes more realistic, we decided to add support for like proper ray bending for specular reflections. And this is particularly useful for like you have an image-based lighting where there's lots of variation in the lighting, and you can really see where the lighting is wrong. So we fixed that with Redshift 2.6. So more stuff for Redshift 2.6. This will be coming out very soon, probably in a couple of weeks. We've had like a pre-release kind of test build for this, so users can try it out. Is post effects. So we're hoping that we don't want like users to like take all their images and they've spent all their time rendering and then they have to take that to a separate package and then start tweaking the post effects in that package. We wanted to make it like easier for them so they can actually tweak it in the render view and get like real-time feedback. So first and foremost, we added bloom. So I think everybody knows what bloom is. It's like that kind of dreamy effect. It's very popular with like 1960s TV shows. I don't know if anyone ever watched Star Trek from the 1960s. So I like to call this the Shatner effect. So you have like full Shatner control. It's really like really glamorous stuff. Flare. This is, I guess, a bit more modern Star Trek. Like J.J. Abrams really loves his flares when you see the sun and things. So this is like great for seeing those kind of hexagonal shapes as they come towards the camera. And we've got full controls for that, including like chromatic aberration tweaking as well. And also streaks. So this is a really nice technique for like when you have those really hot speculars and lights. You want to get the speculars to really pop, and you get those kind of streaking effects on the lens. So you're like full control for that. You can like different kinds of streaks, and you can have them wide and as well. It looks really nice, very dramatic. And also color control and LUTs. So what these give you is like that kind of final color grading to make your images like more atmospheric, more dramatic, you know, without having to like relight your scene or anything like this. So this is very important for comp. So all these new like tricks and techniques, we've got like tons of flexibility, but you don't need like a physics degree to understand them. They're very simple to use. They're just like single sliders with some like color pickers and things. So we want to make it nice and flexible for you. And also, these are like real-time in the Redshift render view, so you can get that real-time feedback. But we also support baking this out in batch rendering as well, so it'll bake it down to your final frames. And we're also going to be adding support for a separate AOV as well. So if you're doing all your lighting in comp, you'll be able to take your post-effects AOV and just slap it on top, and then you get the beauty. Okay, so this is kind of like a big one. Redshift 3.0. So Redshift is already the fastest renderer out there for production rendering, and we want to make it even faster. And we don't only want to make it even faster, we want to make it easier to use as well. We've had quite a few complaints that Redshift can be a little bit complicated to use. So how are we going to do that? So the first thing we're going to do is we're going to be refactoring the core. And then what we're going to be doing is we're going to be increasing the trace depth limit. We've had quite a few complaints in the past that we had a trace depth of 16. That was for both like light bouncers and transparencies, and people were saying, you know, guys, this is just not enough. You know, I want better lighting, and I want to be able to like render hair, which needs quite a lot of deep trace depth, and they just couldn't do it very well with Redshift. So we're going to be changing all of that. So we're going to be increasing the indirect light bouncers to 64, which we hope is enough, and also like straight transparencies, you'll be able to go to like 256 trace depth deep as well. And if that's not enough, just come and talk to me afterwards and I may increase it, if you like. So faster rendering. So this is very important new change in the core. So when you have like deep bouncers, when you have lots of rays bouncing around your scene, they tend to extinguish the deeper they go. And what that means when you're doing GPU rendering is that the GPUs are being underutilized, which means you get very poor performance. So one thing that we wanted to make sure with Redshift 3.0 is that we had to solve that problem. So what we've done is we have solved that problem, and what we found is that we can actually use less memory for rays on your GPU and get much better performance than you would today using automatic memory management, which means you can use more memory for geometry or textures. And what we found out is that with a really chronic, really kind of horrible scene with lots of like reflection and refraction and bounces, we've seen performance improvements up to 3 to 4 times than what it is today with Redshift 2.6. So we're pretty pleased with that. And but regular scenes that do kind of shallow bounces, we've seen an improvement with that too. So you expect about 10% performance improvement with that too. And kind of importantly, this kind of paved the way for migrating parts of Redshift to work with NVIDIA's new Quadro RTX card. So I guess you all know, everyone's talking about it. It has hardware accelerated ray tracing using the Turing architecture, so that's something that we want to use as well. So over the next few months, we're going to be migrating certain parts of the tracing pipeline of Redshift into using Optics. And Optics is NVIDIA's APIs for getting access to that hardware technology. So we're pretty excited about that because, as I've just mentioned, Redshift is going to be faster anyway. And couple that with this hardware ray tracing, we're hoping for like crazy results. Very exciting times. Now another thing, automatic sampling. So this is part of our effort to make it easier to use Redshift. So we want to take away some of the pain of having to fiddle around with like the number of samples for different layers of transparency or reflections. When you've got hundreds of materials, it can be a real nightmare to kind of manage all that and get like the best quality results. So we're going to be adding like, say, probably one noise metric control. So it says how noisy do you want your scene, and then Redshift is going to take care of choosing all the samples for all the different layers and effects to get the best quality results. And what this means is that not only is it easier, it's actually going to be faster as well, because you're going to be wasting fewer samples. And if that wasn't enough, we have even more aggressive optimizations planned. So if you recall, I mentioned that we're going to be increasing the trace depth to 256 for straight transparencies. Oh my god, I'm looking at the time. And I think I'm pretty good. And so that's going to be slow, right? If I'm going to, cranking up my transparencies, what's going to happen? It's going to tank. Actually, it's not. Because we have some ideas for like for basically optimizing for straight transparencies only. So you can expect, I'm anticipating, that even if you crank up all those transparencies, the time is going to be even less than it is today, given these optimizations that we have planned. And we also have some many lights optimizations planned as well. There can be situations where you have a building with lots of little lights in it and you're casting light onto the street, or even if a wall is blocking that light. Well, currently Redshift has no way to know whether walls exist and block lights, and we just sample them anyway, which is dumb. So we're going to be doing something about that to make it even faster for the many lights situation. And so the take-home message here is that we're excited about faster rendering, because faster rendering means more iteration, which means more creativity, means you can crank things up, and the ultimate goal is to get better quality images. So we always have more new cool stuff coming in the future. This is just like a list of some of them. We've got like light blockers. This gives you like really good control over your lighting and your scene for like extra drama. Toon shading. We're actually talking to like a top studio in Japan about how to do it best. These guys are experts at this. We have to do some reworking in the core of Redshift to support this, but once we've done that, we're going to have like a really cool toon shader for you. And distributed remote rendering. At some point, we're going to be having it so that you can probably have like just a dumb computer without a GPU in it, and you can like send out all the data to like offline on the cloud or anywhere like that, or like in a local network or someone else's machine, and actually render on those machines as well through our system. LPEs, that's light path expressions. This will essentially complete our like suite of custom AOV technology. This means you can basically choose any data from any shader at any point and any bounce and write it to an AOV file if you want. It's crazy stuff. I don't know why people want to do that, but they do. Maya Fluids, XGen IGS support as well. And also the mythical shader SDK. Like every year I announce this, and then every year I don't deliver. But I promise I might deliver something by the end of this year, although it's already August, so we'll see. Anyway, so if you want to try Redshift 3.0, we have like a sort of a sample version at our booth. You can feel free to pop over and I can show you some of the difference in performance improvements. And any questions, or just come and chat to us at the booth. Thank you.